Hi class, Mikko here, and today we're diving into solving systems of equations using the substitution method. First, let's review what system of equations are. A system of equation is a set of two or more equations with the same variable. When we solve a system of equations, we are trying to find the value of the variables that make the equations true at the same time. Usually, when it comes to solving two linear equations, we use a graph to see where they intersect to find a solution. So for this example, we have y equals 2x plus 2 as our first equation, and we have y equals x minus 1. When we're graphing these two equations, we can see where they intersect at -3, -4. This will indicate a solution to our system of equation. Some real-life examples of system of equations involve finding out where two cars will collide, where two planes collide, or how many adult tickets and children tickets you've sold, or how many popcorns and soda cans you've sold. So for the substitution method, this involves solving one equation for one variable and then substituting that expression into the other equation. Here there is generally 5 steps that we want to follow. The first step is simplify the given equations. 2. Solve for the one variable. 3. Substitute the solution. 4. Solve the new equation. And 5. Find the value of the second variable. For these examples, we're going to follow these 5 steps using the substitution method. For example 1, we have two equations written in standard form. Our first equation here is 2x minus y equals -2, and our second equation here is x minus y equals 1. Remember that our first step here is simplifying the given equation. Here we can take the first equation and solve for y, which is our second step, solving for one variable. And writing this in slope-intercept form allows us to solve for that y variable. So I'm going to write my first equation here, 2x minus y equals -2, and solve for y, which will be -y equals -2x minus 2, y equals 2x plus 2. So rewriting the first equation and solving for y allows us to substitute that 2x plus 2 to the second y in the second equation. Now we can go into step 3, which is substituting the solution. Since we know that 2x plus 2 is our y, we can take the second equation, x minus y equals 1, and plug that into the y value. It will look like x minus 2x plus 2 equals 1. And here we can just solve for x. X minus 2x minus 2 equals 1. We have -x equals 3, and x equals -3. Now that we know that the value of x is equal to -3, we can solve for y. We can plug in -3 in the first equation and then solve for our y. 2x minus y equals -2, and we plug in -3. 2 times -3 minus y equals -2. This will be -6 minus y equals -2. Y equals 4, and y equals -4. Now that we know our x and y, we can determine the solution to our system of equation, which will be x equals -3 and y equals -4. In our second example, we have two equations as well, and our first equation is 2x plus 5y equals 19, and our second equation is y equals 3x minus 3. Here, in our second equation, we have y equals 3x minus 3, which tells us that 3x minus 3, we can substitute that to the y in the first equation. Substituting this in the first equation, we get 2x plus 5 times 3x minus 3 equals 19. Now we can solve for x. We have 2x plus 15x minus 15 equals 19. This simplifies to 17x equals 34. X is equal to 34 over 17, or x is equal to 2. Now that we know what the value of our x is, which is 2, we can plug in this 2 to the x over here in our second equation. Y equals 3x minus 3. Y equals 3 times 2 minus 3. Y equals 6 minus 3, which is equal to 3. Since we know now that x is equal to 2 and y equals 3, we can say that our solution for this system of equation is 2 to 3.